This is the second example under practical implications, and it discusses the factors that impact the production capacity for batch and continuous coating processes. Suppose we want to use the model to help us increase the production rate without compromising the quality. How can we use the model to give us a higher production rate? Well, we can start by creating a graph like this one, which is generated by keeping the coefficient of variation constant while increasing the pen diameter and pen loading. If we want to get to higher production rate, this model says that we have to decrease the pen diameter and decrease the pen loading. For many of you, you guys are thinking, well, this is not what we're accustomed to in batch processing. And we'll talk about why that is the case in batch processing. But for continuous and semi-continuous coating processes, where the changeover time is almost negligible compared to the overall coating time, smaller pen diameters and shallower beds will favor higher production rates. So for batch coating processes, we have to consider the changeover time, and when we include the changeover time into the overall cycle for the coating process, then the impact of pen diameter reverses, and increasing the pen diameter results in higher production rate. The same can be said about the pen loading, but only up to a certain point. At a certain point, increasing the pen loading actually decreases the production rate, and this is because with deeper beds, it takes much longer to get to the same coating uniformity level. So this is where the model can be very useful in defining or helping us find the optimal conditions for highest production rate while keeping the quality constant.